Mineral from space that's harder than diamond. Today we got our beanless coffee here, also known as water.
Even if you didn't go through a rocks and minerals phase as a kid, you've probably heard some facts about those sparkly, sparkly diamonds, like that they're the
Is it just me, or did we all go through that phase? It seems like when you're a young kid, you go through that phase of loving minerals, loving rocks, and then you get a little older and you kind of grow out of it, but then you get like older, like an adult, and it all comes back to you and you're like, man, this rock is cool.
hardest mineral on Earth, and that they're a dog's best friend. No, wait, that's not how the song goes. Dogs are a girl's best friend. Anyway,
Diamonds are a dog's best friend? Wow, have I had that wrong?
it turns out that first fact might not be right either. There's another naturally occurring mineral out there that could be harder than diamond. It's just a little hard to study because it's only found in rocks that fell from space.
Well, then isn't it safe to say that diamond's still the hardest mineral on Earth? No, it's the hardest mineral from Earth.
Geologists describe a mineral as hard, they aren't talking about how it feels to the touch. They're talking about how scratch-proof it is. You may have heard diamonds have a hardness of 10 out of 10. That's according to the Mohs mineral hardness scale. And the test behind this scale is really simple. You drag one mineral across another. If you see a line left behind, whether with your eye or under a microscope, that mineral is less hard than the one you scratched it with.
So would something harder than a diamond be an 11?
A mineral's Mohs number, the fewer minerals it can be scratched by. So,
okay, we got to look at this. So we got a fingernail's 2.5, a steel nail 6.5, diamond 10, quartz is a 7. Okay, talc. I don't know what that is, but it's only a 1, so that's got to be really soft.
with their hardness of 10, diamonds are nearly unscratchable. They can scratch each other, and while some synthetic materials might be able to scratch them, we haven't found a naturally occurring mineral that can. But what makes diamonds so hard? It's partially due to the fact that they're made entirely of carbon atoms. When atoms come together to make minerals, they form a lattice held together by chemical bonds. Depending on the atoms involved, these bonds come in two main flavors, ionic bonds and covalent bonds. In ionic bonds, electrons are transferred from one atom to another. And ionic bonds can be strong, but they aren't usually as strong as covalent bonds, where electrons are shared. Corundum, the
Naturally occurring diamonds are a hardness scale of 10, right? What about the synthetic diamonds that we create in labs? Are those actually as hard as a normal diamond, or does the difference in the process actually make them slightly softer? But I would imagine that they're probably slightly softer than a naturally occurring diamond. Is that one of the ways you can tell them apart? Because I know that there's ways to tell them apart. I just don't know what those are. My wife would, but I don't.
mineral that makes both rubies and sapphires has both types of bonds.
What? Corundum makes rubies and sapphires? Am I an idiot for not knowing that?
Are shared. Corundum, the mineral that makes both rubies and sapphires, has both types of bonds. Its aluminum atoms will transfer electrons to nearby oxygen atoms to form ionic bonds, and the oxygen atoms will covalently share electrons between each other. So in the end, it has a Mohs hardness of 9. Because diamond is pure carbon, it only uses covalent bonds, but that alone can't explain why a diamond is harder than a ruby. Despite looking completely different, graphite is also pure carbon, and while diamonds are over here rocking a 10 in Mohs hardness, graphite ranks about a 1.5. It's so soft that your fingernail can dent it. So we also have to consider the shape of the mineral's lattice, how the atoms are actually arranged. Graphite atoms come stacked in two-dimensional sheets. Each carbon atom is bound to 3 others in the same sheet. And while the covalent bonds within the sheets are strong, the sheets are bound to each other very weakly. When force is applied to graphite, like you pressing your pencil lead against a sheet of paper, the structure deforms pretty easily. Meanwhile, a diamond's atoms are arranged in a 3-dimensional cubic structure, with each carbon atom bound to 4 of its neighbors. Unlike graphite, it resists force from 3 dimensions.
That makes sense because graphite is very flaky. Yeah, that would make sense that the bonds are only in 2 dimensions then, whereas diamond's in 3 dimensions. But then you also have to consider, when it comes to the bonding, how many electrons and all that are bonding. Is it 1, 2, 3, 4? I think diamond has 2 covalent electrons. Maybe. Probably not, though, because I said it on video. So almost certainly that's wrong. So check that for yourself. I want to say it's 2, though. in the outermost ring for some reason. Okay.
So, hypothetically, if we wanted to find a mineral harder than diamond, we'd look for something that was still pure carbon, but had a better lattice structure. Enter lonsdaleite. Lonsdaleite's atoms are arranged hexagonally. Each carbon is covalently bound to 6 other atoms. These 2 extra bonds per atom should produce an even harder mineral. Unfortunately, scientists have had a hard time confirming that's true, because while we've known about lonsdaleite since the 1960s, we haven't found pure lonsdaleite in large enough samples to really test it.
So lonsdaleite is very rare. I've actually never heard of lonsdaleite before. Is it not possible to make it in a lab, or is it just extremely expensive to do so?
See, lonsdaleite is natural, but as far as we know, it doesn't occur naturally on Earth. The only lonsdaleite we have comes from a special class of meteorites called uraelites.
That would make sense as to why I've never heard of it before, if the only source we know of is in a meteorite. Okay.
These are carbon-rich meteorites that scientists think all come from the same source, a dwarf planet that was destroyed by a collision very early in the solar system's history. And when you crack uraelites open, you can find some graphite, diamond, and, at least in a few samples, teeny amounts of lonsdaleite. Sometimes you can even see transition zones between these different minerals. That suggests that some kind of shock forced the carbon atoms to rearrange themselves, and for some reason, some formed diamond while others formed lonsdaleite.
That's actually really interesting. And that's also another super curious thing about nature. And I know that we probably have a lot of these answers, but I personally don't. The same material, the same base materials can form into vastly different things based on their surroundings.
Researchers are still working on what that reason is and on the exact conditions of that shock. But if they can figure it out, they could maybe find a way to create their own harder-than-diamond mineral. So far, the science is leaning toward rapid depressurization. Since uraelites also contain minerals that exist deep inside the Earth, they all probably started off under a lot of pressure. But when the dwarf planet got blasted apart, all its insides would have suddenly been exposed to the near vacuum of space. One hypothesis proposes that upon this sudden change in pressure and temperature, the bonds between some of the carbon atoms could have suddenly shifted and morphed into diamond's cubic lattice. Lonsdaleite came later. But a study published in 2022 suggests it's the other way around. The uraelites' carbon atoms were shocked into forming lonsdaleite first, and most of that lonsdaleite shifted into diamond when the new meteorite cooled off quickly. So, if researchers hope to make not just their own lonsdaleite, but enough that they can run tests to prove it's harder than diamond, they need to figure out how to replicate this process.
And that actually sounds like a very expensive process because you have the high pressure, the high temperature, and the ability to quickly change one or both of those parameters very rapidly. So that sounds, and a lot of guesswork too. So that sounds like it would be pretty expensive and timely to actually test since we don't fully understand how it's made. We'd have to play around with those parameters a bit. What temperatures are we talking about? What pressures are we talking about? How long? What stage do you have to adjust either the temperature or the pressure? Or both? That could get expensive really fast.
And to keep their new lonsdaleite warm enough for long enough not to decay into a diamond. There's actually been some success here. Back in 2021, one team claimed they'd not only made lonsdaleite, they'd also experimentally proven that their sample was stiffer than diamond. Now, geologically speaking, stiffness and hardness are 2 different properties, but you often find that stiffer minerals are also harder, so it's a step in the right direction.
It makes sense. They're definitely not the same thing, but generally speaking, they should probably line up, right?
But you often find that stiffer minerals are also harder, so it's a step in the right direction. Unfortunately, the method they used was a bit, explosive. It destroyed the lonsdaleite they'd created almost as soon as they'd finished testing it. But if further research backs this study up, and the team can work out all the kinks,
Diamond anvil used to make nano-sized lonsdaleite.
we could eventually have a reliable way to produce synthetic lonsdaleite. And if it does turn out to be harder than diamond, industry will love it. Because they're so hard, diamonds are used for all sorts of cutting, grinding, and polishing jobs. An even harder material would make tools even more effective and last longer. Maybe one day we'll all have lonsdaleite-tipped drill bits. And if we can make them big enough, people may rock some lonsdaleite bling and write a song about how awesome this space-based mineral is.
So who's lonsdaleite's best friend? Because if diamonds are a woman's best friend, lonsdaleite have to be someone's best friend, right? Do men get lonsdaleite? Can we have that? We need one too, okay? It can't just all be woodworking and bourbon for us. We need a mineral.
Minerals rock. For more on minerals, you can check out this video's sponsor, Wondrium. Wondrium.
Ha! I see what you did there. Minerals do rock. This is really interesting. These guys have some really cool videos, so I think we'll probably check more of them out. Anyway, thank you so much for watching. If you made it this far, do me a favor and go ahead and hit that subscribe button to see more. Appreciate you. Have a wonderful day.